So today we are going to start discussing another normal form, and that is Boyce-Codd Normal Form, or popularly known as BCNF. Before discussing BCNF, talk about the general definitions of 2NF and 3NF. So far in our discussion, we have defined second normal form and third normal form. So second normal form was based upon the partial and full dependencies, whereas the third normal form was based upon the transitive dependencies. So the earlier definitions for 2NF and 3NF disallow the partial or transitive dependencies on the primary keys. So in our definitions, we said that no non-primary key attribute. No non-primary key attribute. So we considered only primary key, right, for partial or transitive dependencies as far as 2NF and 3NF are considered. But more general, if we would like to define 2NF and 3NF, we need to consider the candidate keys instead of only the primary key. We know the difference between the primary key and candidate key. For a relation, we may have more than one candidate keys, and out of those candidate keys, we designate one candidate key as the primary key that we know, right? So far in the definition, we considered only the primary key, one primary key of the relation, right? But if we would like to generalize those definitions of 2NF and 3NF, instead of considering only primary key, we are considering the candidate keys of the relation. So the general definition of 2NF now becomes like this: a relation that is in first normal form and every non-candidate key. See here, we are saying every non-candidate key. Earlier, we were saying and non-primary key. Every non-primary key attribute. That was the earlier definition. Now, while generalizing the definition of 2NF, instead of considering a single primary key, we are considering all candidate keys. So we are saying that a relation that is in first normal form and every non-candidate key attribute is fully functionally dependent on any candidate key, right? So that is the difference. So obviously this form of 2NF, general definition of 2NF, is somewhat complex than the earlier definition, right? And it is putting more constraints, right? Similarly, if we go for general definition of 3NF, once again, here also we say that a relation that is in first and second normal form and in which no non-candidate key attribute is transitively dependent on any candidate key. So here also we are not simply restricted to a single primary key, but we are more generally saying that no non-candidate key attribute. So we may have more than one candidate keys, and we are generalizing the concept to all those candidate keys. So once again, this general definition of 3NF becomes more complex and it will put more constraints, right? So I hope you must have understood the difference in general definition and the definitions those we have discussed earlier, right? So definitions actually put additional constraints on the relations. and these definitions may identify few hidden redundancies in the relations. Right? So obviously the process of normalization, if we use these definitions, would be more complex. Okay, fine. So let's proceed now once again with our example of dream house. So we have discussed this example for discussing the earlier normal forms. Those were 1NF, 2NF and 3NF. So once again we are referring to this dream house case study. Assuming client rents a given property only once and cannot rent more than one property at any one time. Right? So we have seen this problem statement earlier and we have discussed 1NF, 2NF and 3NF for this problem. Okay, now we are extending this dream home case study to include a description of client interviews by members of staff. So now, apart from the earlier information that we stored in our dream home database, we would like to store some more information related to client interviews. And what that information is, we want to store the information like the staff members are carrying out the interviews of the clients on a particular interview date and time, right? And these interviews are scheduled on those particular dates and times for the respective clients, and to conduct those interviews, some room numbers are allocated, right? So we would like to store the information like which client is having interview on what date, what is the time of the interview, who is the staff who is conducting that interview, and what is the location for that interview. So this information additionally we would like to store in our dream home database system, right? So please see here, few statements are being provided from which may extract some functional dependencies for this relation. So what is the information provided? Let us go through. The members of staff involved in interviewing clients are allocated to a specific room on the day of interview. So staff members who are conducting the interviews on a particular date are allocated a specific room to conduct that interview, right? However, a room may be allocated to several members of staff as required throughout a working day. This means that not necessarily one room is allocated to one staff, but one room may be allocated to more than one staff. Say for example, if we look at this information that we have, what we see here is, this room number G102, right? So this G102 is being allocated to two different staff members. Also, we can observe here that this staff number SG5 is having 3 interviews scheduled, right? So the interviews, those are conducted on same date, are at same location. But for the same staff number SG5, the interview that is conducted or that is scheduled on different date is having different location, right? So if we look at this data, we may come up with several functional dependencies. Further, it has been mentioned that a client is interviewed only once on a given date, but may be requested to attend further interviews. Right? What does this mean? See here, this is one client CR56. On this particular date, 13th of May, this particular client will appear for interview only once on the given date. But for the same client, it is possible that few more interviews are scheduled on different dates. So for the same client CR56, we are having one more interview scheduled here on 1st of July. Right? So one client may appear more than one interview on different dates. It will not happen that one client is appearing for the interview more than once on the same date. It will not be possible. Okay, so looking at data, the description about the data that has been provided, we may come up with several functional dependencies. Right? So, what are those dependencies? Just look at it. We have identified few candidate keys based on the information that has been provided. So, for this relation, we have identified that client number interview date would be our primary key. Client number interview date would be our primary key. Further, we are having several other candidate keys as well for this relation. So what are those candidate keys? We have identified that staff number interview date interview time would be a candidate key. Room number interview date interview time, that can also be our candidate key. Right? Client number interview date is also a candidate key, and this candidate key is designated here as primary key. Right? So, in essence, we have identified three different candidate keys, which are composite candidate keys, meaning the candidate key comprises of more than one attributes. Every candidate key comprises of more than one attributes. And that is why we say that these candidate keys are composite candidate keys. But if we look at these candidate keys are sharing one common attribute, and that is interview date. So in every candidate key, we are having this interview date common. That is just the observation. Right? Are you getting me? Yes.
Yes, ma'am.
See, please, if you have any doubts, please interrupt me and ask your doubts. Right? So these are very important concepts. And that is why, in case if you are not able to understand the concepts, please interrupt and ask your doubts. Right? So let us proceed now with our discussion. So as I stated, we have identified three candidate keys. One of the candidate keys is designated as the primary key. Right? Now, further, if we look at the information that has been given, we may come up with one more functional dependency. And what that dependency is, see here, staff number interview date determines room number is the functional dependency that we are identifying here. What is the dependency? Staff number interview date is determining room number. Do you agree with me? Is this the valid dependency that we may have? Yes? Just look at this dependency. What we are saying? Staff number, interview date determines room number. In fact, in our description, we have been provided with one statement. The members of staff involved in interviewing clients are allocated to a specific room on the day of interview. So for a specific staff on a specific date, a specific room number is been allocated. That is, the statement is given as like this. The members of staff involved in interviewing clients are allocated to a specific room on the day of interview. Right? So, a specific staff number on a specific date has been allocated with a specific room number. Right? And that is why we are having a functional dependency like this. We are not saying that staff number determines room number. Is this the valid dependency? Staff number determines room number. See here, staff number SG5, room number G101. Staff number SG5, room number G101. But for the same staff SG5, we are having here another room number G102. So only staff number will not determine room number. So this is not valid. But staff number on a particular date, staff number on a particular date, right, will be allocated a specific room. So staff number interview date will determine room number, because on a particular date the same staff number is allocated the same room number. Got it? And that is how we have come up with this functional dependency. Are you getting me? Yes?
Yes.
Are you? So clear with this dependency, staff number, interview date determining room number?
Yes.
Fine. So let's proceed now. This is our relation. We have identified primary key as client number, interview date, right? So we want to know whether this relation is in 3NF. We have identified these dependencies, right? So what we want to know is whether this relation client interview is in third normal form. What our third normal form says, what is the definition? It should be in 1NF and 2NF. So our relation is in 1NF and 2NF, no doubt. And the second condition says that every non-primary key attribute should not be transitively dependent on primary key. Right? So if we look at this dependency, no problem with these functional dependencies FD1, 2 and 3, because all are my candidate keys. So no issues with these dependencies. Right? One more important point you may consider while discussing 3NF, that if we are talking about a functional dependency of the form alpha to beta, right, and if this is my candidate key or this is my super key, right, and if all the dependencies are having the determinant as super key, right? Then we need not consider those dependencies. Definitely the relation would be in 3NF. Okay, so if we are talking about these first three dependencies, these are the candidate keys. So always if the dependency is a candidate key for the relation, there will not be any problem to declare the relation whether it is in 3NF or not. It is always in 3NF. But in addition to these dependencies, we are having one more, right? So we need to think of, or we need to pay attention to this dependency. And we need to check whether this dependency is violating our rule of 3NF. So if we look at this dependency, staff number, interview date, determining room number, right? Then obviously we may say that there is no transitive dependency. This is not the transitive dependency as such. So if we come up with a transitive dependency on the primary key or in general on the candidate key, then we may say that the relation is not in 3NF. But here, whichever functional dependency we are looking at, this is not the transitive dependency. Right? So even though this staff number, interview date is not a candidate key for the relation, this functional dependency is allowed in 3NF. Right? Because room number, which is the right hand side of the dependency, is part of one of the candidate keys. This right hand side room number of this dependency is part of one of the candidate keys, and this is allowed in 3NF, right? And that is why we may say that this relation is in 3NF. No issues. Okay, but now if we look at this particular relation, whether this relation suffers from any kind of update anomaly, yes, whether this relation suffers from any kind of update anomaly, or in other words, I may pose a question like whether there is any kind of redundancy in this relation. Yes. Is there any kind of redundancy exist in this relation? I'm expecting the answer from you people. We declared that this relation is in 3NF. No doubt. Okay. But if we look at now this relation, whether there is any kind of update anomalies, or in other words, if whether there is any kind of redundancy present in this relation. Yes. If we look at this instance, on date 13th of May, this staff number SG5 is allocated this room G101, right? And on the same date for same staff number, in this particular relation we are having two entries, right? So it may happen that one staff is conducting several interviews of different clients on same date. Do you agree with me? Yes? Are you getting me or not?
Yes, ma'am.
So, so meaning if the same staff is conducting more than one interviews on the same date, right? Obviously, that staff is allocated with same room number. So if for this particular staff, if I am having 10 entries on same date, because this staff member is conducting 10 interviews, let us assume, then this room number will be repeated for 10 times. Is that correct? Here, in this instance, the room number is repeated twice because this staff number SG5 on 13th of May has allocated room number G101 and this staff is conducting 2 interviews on that date, right? So the same room number is repeated twice here. So if by some reason, if it happens that the room number allocated to SG5 needs to change due to some reason, then obviously if the room number allocated earlier to this SG5, if that room number needs to be changed, then obviously all the tuples need to be changed. All the tuples need to be updated. So here, say for example, for this staff SG5 on 13th May, earlier this staff on this day was allocated with G101. But now, due to some reason, that room number needs to be changed to, say for example, G105. So in this case, what we need to do is, as in this particular instance, we are having 2 tuples, we need to modify these 2 tuples such that room number is now G105. Are you getting me? Yes?
Yes.
And that is why we are saying that this relation suffers from update anomalies, meaning there is still some redundant data. So if we forget to change the room number for one of the tuples, then it may happen that our data becomes inconsistent. Right? So why we are saying that there is update anomaly? Because to change the room number for staff number SG5 on 13th of May 14, we must update 2 tuples with respect to this instance. Right? So what I want to convey is, though this relation is in 3NF, third normal form, it may suffer from update anomalies. So even though the relation is in third normal form, we may have some redundancies still present. Right? So if we want to reduce or if we want to remove those redundancies in 3NF, we need to go for still higher normal form, and that is known as Boyce-Codd Normal Form, or it is abbreviated as BCNF. This normal form was introduced by 2 scientists, and those were Boyce and Codd, and that is why the name BCNF, Boyce-Codd Normal Form. So to remove the redundancy that may exist in third normal form, we are coming up with still stringent normal form than 3NF, and that is known as BCNF. Let us try to define BCNF. A relation schema is in BCNF with respect to the set F of functional dependencies. If for all functional dependencies in F plus of the form alpha to beta, where both alpha and beta are subsets of R, at least one of the following holds. So, what is the first condition? A determining B is trivial, meaning beta is subset of alpha. Or, for every dependency in F plus, alpha must be a super key for R. I repeat, what are the conditions? Either one of the conditions must be satisfied for a particular dependency alpha to beta in our F plus. So what is the condition? Either the dependency is trivial, meaning beta should be subset of alpha, or alpha must be the super key for relation R. So see here, if we look at this particular condition, alpha is super key for R. This is really very stringent. So this condition makes the BCNF more stringent. Why? Because if the functional dependency in F plus is not trivial, then always it should represent a super key. So determinant or the left hand side of the functional dependency must be the super key for R, and this should be true for all the dependencies, right? And this is a more stringent condition that has been imposed. But if we satisfy this condition, then it is possible for us to remove the redundancy that we had in 3NF. Okay, so in other words, we may write this definition as a relation is in BCNF if and only if every determinant is a super key. In simple words, we may say that. Further, the entire database design is in BCNF if each member of the set of relation schemas comprising this database design is in BCNF. So if I'm talking about my university database, say for example, right? And if I'm having several relations R1, R2 up to Rn in this schema, then when I will say that my university database is in BCNF, if and only if every relation in this university schema is in BCNF, then and then only I will say that the entire schema is in BCNF. Right? Now, I hope you must have understood the definition of BCNF, which is more stringent than 3NF. Okay? Now, let us see the example of BCNF. So, as we have seen, our client interview relation is having this dependency staff number, interview date, determining room number. Right? So, we said that this dependency is allowed in 3NF, and that is why we declared that client interview relation is in 3NF. Right? But due to this dependency, we are having some redundant data in our 3NF relation. So, what we need to do is, we need to check for this dependency. So, if we look at this dependency, then whether this dependency satisfies the rule of BCNF. Whether this dependency satisfies the rule of BCNF. What our rule says, if I am having a dependency of this form alpha to beta, either this dependency is trivial. So first rule, this should be trivial dependency. What we mean by trivial dependency? Beta must be subset of alpha. So whether this condition is true in case of this dependency. This is my alpha and this is my beta. Right? So whether this dependency is trivial, whether beta is subset of alpha.
No, ma'am.
No. So the first condition is not satisfied. Right? So let us check the second condition of BCNF. We are talking about BCNF conditions. So what is the second condition of BCNF? In case of dependency alpha to beta, if the first is not satisfied, the second must be satisfied. And if the second gets satisfied, then only we will say that the relation is in BCNF. Otherwise, no. So the second condition says that my determinant, that means my LHS, that means my alpha, must be the super key of the relation. So if I look at this staff number interview date of this functional dependency, staff number interview date, whether this staff number interview date determines all other attributes of the relation, then and then only we will say that this is my super key. But if we look at our instance of the relation, then we may come across the situation where staff number interview date is not determining all the attributes of this relation, and that is why staff number interview date is not my super key. So this second condition is also violated, right? And that is why we say that even though my relation client interview is in 3NF, it is not in BCNF. It is not satisfying the norms for BCNF, Boyce-Codd Normal Form. So what to do? To convert our client interview relation in BCNF, what we need to do is we need to remove such kinds of functional dependencies. Those are violated under BCNF. So we need to decompose client interview relation now by removing this functional dependency, which is violating my BCNF rule. Right? So we are having this relation client interview. So what we are going to do is we are going to decompose. We are going to decompose our relation by making use of this dependency that we have identified, which is violating the norm of BCNF. Okay, so simply we are applying the rule for decomposition. So we are having this functional dependency that is violating the rule. So simply while decomposing this relation, what we will do is we will make use of these attributes in this functional dependency, and we will come up with a separate relation. See here, staff room is a separate relation now, having the attributes from this functional dependency. So in staff room relation, we will be having staff number, interview date and room number, 3 attributes. Okay, so we have done with staff number, interview date and room number. Okay, now whichever are the remaining attributes, say for example this client number, interview time, those are remaining attributes. Okay, so what we need to do is we need to come up with the another relation wherein we are having this remaining attribute client number, interview time. Also, we need to have this primary key of staff room relation that should be included in my interview relation. Okay, so staff number, interview date should also be present in this interview relation. So my interview relation will have 4 attributes: client number, interview date, interview time and staff number. So now after decomposition, our client interview relation is decomposed into interview and staff room. Interview relation will have 4 attributes and staff room will have 3 attributes. Is that correct? So earlier, what was the redundancy in client interview relation? Let us go back. In client interview relation, we had the redundancy. And what was the redundancy? If on the same date, the same person is having more than one interview scheduled, then room number was repeated. Correct? And that was the redundancy in 3NF. So what we have done now is we have converted this relation in BCNF by making use of this dependency, staff number, interview date determining room number. Right? And we have come up with this separate relation staff room, wherein we are having staff number, interview date and room number. So for a particular staff number on particular interview date, this room is been allocated. So if we would like to change the room number for a particular staff on particular date, we need to update only one entry because there is no redundant entries now on the same date for same staff number. Right? So only once we need to modify this room number if it happens that the room number is changed. In earlier case, whenever our relation was in 3NF, due to the schema of 3NF and due to this functional dependency, we have to change more than once the room number if it happens that the room number is changed on a particular date for a particular staff, right? But now we have decomposed the relation and we have removed the redundancy. So it is possible for us now to remove the redundancy in 3NF. And we have come up with now this BCNF decomposition. Right? And that is why we said that BCNF is more stringent than 3NF because it is not allowing any redundancy now. Okay? But BCNF is not always desirable. BCNF is not always desirable. Why? What is the reason why I am saying BCNF is not always desirable? No doubt, if I am having the relations in BCNF, I will not be having any redundancy. But there is a problem in BCNF sometimes. And what is that problem? In BCNF, it may happen that few of the dependencies are not preserved. So BCNF may not preserve the dependencies. What we mean by dependency preservation? We have a discussion at length regarding this dependency preservation, right? So in simple words, what we mean by dependency preservation? If I am having a dependency and if to check for that dependency, if I need to compute join of two relations, then I will say that that dependency is not been preserved. And without computing the join of two relations, if I am able to check for the functional dependency, then I'll say that my dependency is preserved after decomposition. Now, if we look at this dependency, room number, interview date, interview time, determining staff number, client number. We are having this dependency, room number, interview date, interview time, determining staff number, client number. Right? Now, if we want to check for this dependency, this is our decomposition, BCNF decomposition. And if I want to test for this dependency, then if I look at the attributes in this relation, right, then the staff number is present in this relation as well as this relation. But this client number is present in this relation only. Room number, interview date, interview time. Room number, interview date, interview time. So interview date and interview time are present in interview. But if I want to check for this dependency, in left hand side, I also want room number. Room number is not available in the same relation. So to test for this dependency, what I need to find the join of these two relations, because room number is available in staff room. Okay, and client number is available in interview. So if we look at all those attributes in the left hand side, few of the attributes are present in one relation, few of the attributes are present in other relation, and if this is the case, then we say that this dependency is not preserved. This dependency is not preserved. Right? So, the disadvantage of BCNF is that sometimes it may happen that few of the dependencies are not preserved. And to check for those dependencies, then we need to compute the joins, and while computing the joins, we may incur some overhead. Right? So, the advantage of BCNF is there is no redundancy, and the disadvantage of BCNF is sometimes the functional dependencies are not preserved. Right? So, if we are having two normal forms, those are 3NF and BCNF, then we should think of, or we should have a wise decision which normal form to be used, whether we should go with 3NF or whether we should go with BCNF. Obviously, BCNF is more stringent than 3NF, meaning BCNF will not allow any kind of redundancy. So if we are more concerned about the redundant data, then obviously we should go for BCNF. But if we are more concerned about testing the functional dependencies, and if there exist the dependencies, those are not being preserved in BCNF, then we should stick to 3NF. Right? So while designing a database, we should always think of this trade-off, whether we are more concerned about redundancy or whether we are more concerned about preserving the dependencies. So in brief, I may say that 3NF will always preserve dependencies. 3NF will always preserve dependencies. Right? But the drawback of 3NF is we may have redundancies in 3NF. Okay? If we look at BCNF, then BCNF will not have any redundancies, but sometimes it may happen that there are certain dependencies, those are not been preserved. Right? And that is why we should have a wise decision whenever we select one of these two normal forms, 3NF or BCNF. Right? If you have any doubts, please let me know. Yes? Is there any doubt? So let me proceed with a formal algorithm for BCNF decomposition. So we are having here a formal algorithm for BCNF decomposition. So let me go through this algorithm. In fact, I have given you the trick how to decompose the relation in 3NF into BCNF, right? So simply we need to pick the functional dependency that is violating the norm of BCNF, and whichever is the functional dependency that violates the norm of BCNF, that functional dependency is being used to decompose the relation. The same thing is being mentioned in this algorithm formally, right? So originally we are saying that we are having the relation R that we would like to decompose. Okay, so initially that relation R is assigned to our result. We are having one flag done that is assigned to false initially. We are having computed our F plus. We are having this iterative algorithm. While not done, do. So while this flag is not true, we are going to iterate true. If there is a schema Ri in result that is not in BCNF. So initially we are having only R, and we know that this is not in BCNF, and that is why we are executing this algorithm. So if there is a schema Ri in result that is not in BCNF, then what we need to do? We need to follow these steps. So we need to pick a functional dependency alpha to beta from this F plus, such that this dependency is non-trivial. This dependency is non-trivial, right? And also this dependency is not the super key of the relation Ri under consideration. Okay, I'll repeat. We need to test for two conditions. What are those two conditions? Alpha to beta is non-trivial, because it is, if it is trivial, then it satisfies BCNF norm. So if alpha to beta is non-trivial and alpha is not the super key of Ri. So alpha is not determining all the attributes of Ri. Right? And alpha intersection beta is phi. That means there is no common attribute in left hand side and right hand side of the relation. If these conditions are true, then for a particular dependency alpha to beta, then we may say that this particular dependency is violating our norm. And that is why by making use of this dependency, we are going to decompose our relation. And how we are going to decompose? See here, the result is now the new result is result minus Ri union Ri minus beta union alpha beta. What does this mean? Whichever dependency that we have identified, which is violating the norm of BCNF, we combine all those attributes together and we come up with a new relation. Right? Another relation would be result, old result minus Ri. Okay? Union Ri minus beta. What does this mean? The relation under consideration, okay, minus the right hand side. Minus the right hand side of this functional dependency under consideration. So this will form only the left hand side, or rather all the attributes other than this right hand side of the dependency. So this will form one relation and combination of alpha beta will form another relation. Right? So these are the relations in our decomposition and we are going to iterate through. Right? Till we are finding such kind of a functional dependency that is violating the norm of BCNF. Okay, so I would suggest you to go through once again this algorithm and try to implement it practically. Okay, now we are going to discuss one more case study, but right now I'm skipping the discussion with respect to that case study. I'll be posting this case study for you later so that you can go through. Okay, but now I'll be simply comparing 3NF and BCNF, and this is the most important comparison of BCNF and 3NF. So please remember these points. It is always possible to decompose a relation into relations in 3NF, and the 3NF decomposition is always lossless and preserving dependencies. It is always possible to decompose a relation into relations in BCNF, and the decomposition is always lossless but may not be possible to preserve dependencies. Right? So in 3NF, the decomposition is always lossless and preserving dependencies, but in BCNF, the decomposition is lossless but may not preserve dependencies. Further, 3NF may have redundancy. 3NF may have redundancy, whereas BCNF is not having redundancy. If a relation is in BCNF, it is always in 3NF. If a relation is in BCNF, it is always in 3NF. Further, BCNF is more stringent than 3NF. Okay, so these are the important points, those you need to remember as far as comparison of BCNF and 3NF is considered. Right? So with this, we conclude our discussion with respect to BCNF. Right? And next time we'll go for few more higher normal forms. So let's conclude today's session. Thank you.